And we're going to start with, I would date and title it, Probability of Independent Events. Okay, let's talk about each piece of this. Probability really is stating the possibility that something could occur. That's what we mean by probability. An independent event means something else does not have to happen for it to happen. It just is happening all by itself. It's not dependent on anything else. And when we talk about events, a lot of times we're talking about drawing cards, rolling dice, making a spinner. You know, we have a set of specific numbers. What's the likelihood of you picking from it? That kind of a thing. Okay, that's what we're talking about with event. So I know that was a lot of breakdown of what each of these things means, but you should be able to, if I ever asked you, define each one of them. Define probability, define independent, and define events. I'm pretty sure you can all, you get the gist of what the word of means, but other than that, I would like you to be able to do that. I will not ask you to define of, so don't worry about it. It's not an English class. We'll be okay. 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 So these are what I'm going to put in front of you is the essential questions. So these are the questions that we want answered in this unit. Okay? Yes. You have to write everything that I put on the board in writing. You need to write down. Do we want to turn off the lights so it's easier to see?
Yeah.
Miles, would you mind? You may not sleep, though.
Especially the people that are watching on the
Okay, that too. Probability of independent events, essential questions. How is the probability of simple, independent events determined? How do we decide what the probability is? And then how is the probability of compound independent events determined? And compound means more than one independent event. Make sure you're writing those down. Those are essential questions. You should always, when you're going into any kind of lecture, have kind of like major questions you wanted answered from it. And so in this case, I'm giving you those. It's like the focus of what we're doing. I heard a little wait, so I'm going to give it another second. Okay. All right. Now, to get through those essential questions, we kind of have to talk about what probability is. And we're going to talk about the difference between theoretical and experimental probability. The probability of an event is a number between 0 and 1 that indicates the likelihood the event will occur. So there's the probability 0, the event will not occur. P equals 1/2. Event is equally likely to occur or not occur. And probability 1. The event is certain to occur. Okay? There are two types of probability, theoretical and experimental. Okay? So P equals 0, event will not occur. There's no way that tomorrow will be Saturday. There's 0% chance. Probability for the event to occur to be half as likely is like flipping a coin. There's a 50% chance land on heads, 50% chance land on tails. Event is certain to occur. I don't know. The sun will rise in the east is pretty much certain to occur. Although I don't think it could be 100% one because there is like a possibility the sun could blow up or something. But you get me. Event will not occur. Event is equally likely to occur or not occur. An event is certain to occur. Okay, are we ready? Ooh, one good example of event is certain to occur. I can't remember which Batman movie it was, but he had a double-sided coin where it was like heads on both sides of the coin. And so there was 100% chance it would land on.
I thought it was one of the double-sided
You can get them. Joke shops and magic shops. So my guess would be Amazon would have it because online has it. All right, next. We have plenty of time to go through all this, guys, so if you need extra time on each page, just let me know. And I do want you to draw the diagram. Theoretical probability of an event. The theoretical probability of the event is often simply called the probability of the event. Number of outcomes in A over the total outcomes possible. Okay, so if we look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. But my outcome only occurs that I want if it's these 4. So what's the probability that I will pick these 4 over the others? 4 out of 9. You can express probability as a fraction, a decimal, or a percent. For example, 1/2, 0.5, or 50%. So what's the probability of picking Matt out of the class? Well, how many students are in the class? 1 out of that. But that's different than how, what's the probability of picking a boy out of the class, right? You'd add up how many boys over how many total. Those are all examples. So we also get that this 4/9 could be written as 4/9 or 44% or 0.44. Okay, the next thing we're going to talk about is dice. So guys, how many sides does a dice usually have, a normal dice? And we get that it has a different number of dots on each side, right?
Yep.
Get ready to draw some dice.
Oh.
Life is so hard.
Math is hard.
We need another second? You roll a six-sided die whose sides are numbered from 1 through 6. Find the probability of rolling a 4. Right? There's one possibility of rolling a 4, so it's 1 over 6, or 0.16, or 16%. If you draw the faces of all the dice, you will. You can just do it once because there's 2 more pages with dice on it. But you want it there to kind of remind you of what it looks like. Okay. Good? Okay. Okay. Yes?
Yeah.
All right. We're going to figure out this solution together. Again, if you've drawn the pictures once, you don't need to draw them next time. You rolled a six-sided die whose sides are numbered from 1 through 6. Find the probability of rolling an odd number. How many of them are odd? So, what would their fraction be?
1/2. You have to simplify every time. Oh.
Or 50% for 0.5. All right, we ready for the next one? You should be writing all these down for sure. Can I turn it? Alright. You roll a 6-sided die whose sides are numbered from 1 through 6. Find the probability of rolling a number less than 7.
100%.
Why?
Come on. Make it harder.
Hey, stop that.
Okay.
No. You dummy.
Okay.
Take that.
So write this one down, but then I want you to find the probability of rolling a 4 and 2. I want you to find the probability of rolling a 4 and a 2.
Nope. 1 over 3.
Somebody open the door from this house. I want you to think about it for a second before you answer.
Can I get that on Nick for a few minutes?
Sure. Nick, this house, please.
Wait, a 4 and a 2 back to back.
Find the read what it says. Find the probability of rolling a 4 and a 2.
Oh,
Four,
zero.
two, like
It's
rolling.
zero.
No.
Yeah, fine.
It's 0.
What did Ethan just say?
0.
Because if I'm rolling one dice, what's the probability of me getting a 4 and a 2?
It's impossible.
Not from one roll, you can't. 0.
But you never said
You didn't say in how many rows.
I didn't, right? So, can I assume it's more than one?
Yes.
No, you can't.
And I said, find the probability of rolling a 4 and a 2.
And.
Yep, at the same
That
time.
definitely implies that you only have
You gotta be more specific.
Okay, want to try another one?
No.
Yes.
Okay.
My,
Find the probability. I'm spelling probability a different way every single time.
one. So am I.
Also, how to spell it.
Oh. I'm going to say P for probability. You know what I mean? Find the probability of rolling a 4 or a
You
2.
gotta be in the first
that's,
one.
2 over, 6.
No. 4
Can you move
over
it?
6.
It's definitely 1 over 3.
How's it 4 over 6?
Find the probability of rolling a 4 or a 2.
No.
It's 1
No,
third.
it's 8 over 12.
It's 1 third.
What?
Where did you get
Why are
that?
you? Yeah,
Two
no,
dice.
no, she thinks 1.
No, it's
I didn't say anything about 2
It's
dice.
still 1.
So 1.
There's
It's-
1
it's
die
1
out of
third.
6.
It's 1
So
third.
it's 1/3. So yeah.
It's definitely
Okay.
1 third.
How many different ways can I arrange it? 1 through 6. So I'm going to choose 4 and 2.
Right.
So there's 2 out of 6, which reduces to 1/3.
How did you get 8 over 6?
He assumed there would be 2 dice rolled at the same time. Okay. You ready for the next one?
No.
Yes.
No. Isn't enough.
No, there's never enough.
There's always enough notes.
Okay,
Tell 'em stop taking notes.
so what we're going to start now is cards.
No.
That's too many.
There are 52 cards in a deck. So what are my chances of picking an ace?
Jays.
There's 4.
Jays.
1 in 13.
Ace of spades is what about the deck.
Okay, so it's just an ace. It doesn't matter which aces are there. And how many aces are there in a deck?
4.
Because there's hearts, spades, clubs, and
Diamonds.
diamonds.
It's 1 in 13.
Because you had
52 cards.
4 over
4 out of
52, right?
reduces to 1/3.
So there are 4. This is what you ask yourself. How many aces are there? Well, there's 4. How many cards are in a deck? 52. So I have 4 over 52, which reduces to 1.
Or you could think about it, there's 13 different types of cards.
Okay, you try.
So let's try some more.
No.
Okay. What is the probability?
Good job.
I'm reading it off another page, but whatever. What is the probability of choosing a spade? Okay, so this is a good question. This is what we talk about. It can be biased because if you don't know cards, you don't know the answer. How many different suits are in the deck?
1 4.
4. So, and how many cards? Right, so 52 divided by 4 is 13, right? So it's 13 out of 52. Can I reduce that?
1 4.
1/4. Okay. So, I got another one.
Oh.
What is the probability of choosing a king? Or queen? Maya, I do have a, I can make you a picture where it literally has every card laid out.
Okay.
What is the probability of choosing a king or a queen? And you just have one choice.
4 out of. I mean, I don't know. I think it's 3. I don't know what's hard.
How many kings are there?
4.
How many queens are there?
4.
So we can add them together and we get
8 over 2 over
8 over 52, which is 2 over 13. All right. So we've kind of started already talking about this, but when asked to determine the event of probability of A or B, it's a mutually exclusive event. Mutually exclusive events cannot occur at the same time. For example, you cannot draw an ace of spades that is also a king of hearts. You cannot draw an ace and a king at the same time. But drawing a spade and an ace is not mutually exclusive because it is possible. Okay, let's do one of your homework problems so we kind of get what we need to do.
We had a test on this.
No.
Okay. I would like to look at number 3 on the front page. We're just going to do 3E. Okay. So, find each probability if you choose one marble at random. Okay? The marbles are striped, black, or white, but how many marbles are there total? 10. How many of them are black? So 3 out of 10 is my answer. Okay? And then I go down here at the bottom, right? 3/10 is E. So I look at the bottom for 3/10 and I put in E. And it's going to answer our question, when the boy tire maker married the girl tire maker, what did everyone say?
This is not black, because I mean it came in like the black stripes.
Not solid black is with an E. Yep. All right. So I'm going to give you the rest of the hour to start your homework. But I'll leave this up here because some people have asked.